How are you, my friends? This is lecture number 14 of Calculus 1 lectures, Newton's method. This is introduction for the Newton's method. It is a method of generating a sequence x1, x2, x3, x4 of approximations to the solution R of a certain equation. Usually, the equation is not easy to solve. Like, I put here an example, f of x is equal to tan x minus x. This is not easy to find the zeros or the roots or the solutions because this function is not algebraic functions. So we will see Newton's method on the next slide and some examples. Newton's method, we have a function here and we need to find the zero or the zeros of this function. So we have to generate a sequence of successive approximations by this formula. X sub n plus 1 is equal x sub n minus f of x sub n divided by f prime of x sub n for n equals 0, 1, 2, 3, 4, 5, 6, etc. X sub 0 is called the initial guess. So usually this is given, and we start here with x n equals 0. So I put 0 here for the n, 0 for the n. So I get x sub 1 is equal x sub 0 minus all this. So I can use that initial guess. Let's look at simple example first. Use Newton's method to find the zero of this function with 3 successive approximations, and x sub 0 is equal to 1. So we start with initial guess 1. So the only thing we have to do after we find the derivative, write the formula for Newton's method. X sub n plus 1 is equal to x sub n minus f of x sub n divided by f prime of x sub n. Now start with initial x sub 0 is equal to 1. So I put here in the n here, I put 0. So I get x sub 1 is equal to x sub 0 minus f of x sub 0 divided by f prime of x sub 0. I know x sub 0 is 1, so I put 1 here, and then I replace 1 in the function, and then I replace 1 in the derivative also. So I start calculating. I get here half, which is 0.5. That's the first approximation of the zero, close to 1. Now I can repeat the process because in the question we need 3 successive approximations. So I put n now will be 1. So x2 is equal x sub 1 minus f of x sub 1 divided by f prime of x sub 1. I put all the numbers. So this number is half here. So I put half, see half here, minus f of half divided by f prime of half. So I replace 1 over 2, which is 0.5 in the function. It will give me all this. Divide by f prime of half. I put half in the derivative. It will give me all this. Then you have to do it yourself. I put the solution for you. So half minus, all this becomes 5 over 16. And this one, minus 5 over 2. When you make the reciprocal here, minus 2 over 5. When you simplify everything, you get 5 over 8. See, this is the second approximation, approximately 0.625. Then you repeat the process for the third time, you will get approximately 0.61. So we are coming close to the solution. Let's see another example here with exponential. Use Newton's method to find the zero. 3 successive approximations we need. The initial guess is minus 1. The function e to the power x plus x. We have to find the derivative first. Now the derivative will be e to the power x plus 1. Same rule for Newton's method. Initial guess is minus 1. So x sub 1 will be x sub 0 minus f of x sub 0 divided by f prime of x sub 0. So you put minus 1 in the function, you get e to the minus 1 minus 1. And then you get minus 1 in the derivative, you get e to the minus 1 plus 1. And this is x sub 0 is minus 1. So be careful. E to the minus 1, 1 over e. This is 1 over e. You have to simplify all this fraction. You get 1 minus e over 1 plus e. Add the fractions again. Minus 2 over 1 plus e, which is approximately minus 0.537. This is approximately here, like this one, like this one. Then you repeat the process for x sub 2, then you repeat the process for x sub 3. Let's see now a nice example. Use Newton's method to find a solution of the equation cosine of x is equal x with 3 successive approximations with x sub 0, which is the initial guess is 1. This is an equation. Remember, cosine of x is equal to x. From the equation, we can construct a function. So we take x on the other side. So we have a function now, cosine of x minus x. See, from the equation, we construct or generate a function. Then we find the derivative. Derivative of the cosine of x will be minus sine of x minus 1. That's a derivative. The initial guess is 1. It's given in the question. And then we find 3 successive approximations with the same Newton's method. You can find x sub 1 is equal x sub 0 minus f of x sub 0 divided by f prime of x sub 0. You put the numbers, you need the calculator sometimes, or if the question is easy, you can use without a calculator. You can check the 3 successive approximations. This is an interesting question. Find the first fraction approximation of cube root of 7. This is very good for an exam. Use Newton's method with x sub 0 is equal to 2. So the initial guess is 2. And we need the first fraction. Here I did not ask for 3 successive approximations or 2. Maybe you need the calculator. For this question now, example 4, you can find it without a calculator. Very nice for the exam. Use the first fraction only, approximation. So x sub 1 of this number, cube root of 7, which is not easy to find or not easy to remember, using Newton's method with x sub 0 is 2. Let me show you how. Let x be the number. We need to approximate this. Cube root of 7. Let x be that number. Cube both sides here. You get x cubed is equal to 7. Friend, this is an equation. Let's construct a function. F of x is equal to x cubed minus 7. Let's find the derivative of that function, 3x squared. We have a function. We have a derivative. We have x sub 0 is 2, the initial guess. Use Newton's method. This is the formula. We need only the first approximation. So it will be x sub 1 is equal to x sub 0. X sub 0 is 2 minus f of x sub 0. So I replace 2 in the function. 2 cubed minus 7 divided by f prime of x sub 0. So I replace 2 in f prime. So it will be 3, 2 squared. This is 2. 2 cubed is 8, right? Minus 7 is 1. And this is 3 times 2 squared. That's 12. Now find the LCD 12. 24 minus 1, 23 over 12. This is the answer. You can find so easy, so nice, without using any calculator. Now, please always check the playlist Calculus 1 Solve Questions to know more questions about Newton's method and to understand the lectures better. This is the end of lecture 14. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.